The bleeding dots. When you peer into a baby photo of the universe and find monsters already grown, the scrapbook stops feeling safe. The early universe was supposed to be a nursery, not a crime scene. In March 2024, James Webb spotted hundreds of specks that should not exist. And the thing that makes them glow red is not what anyone expected. Webb survey teams identified them as a new class of object, the little red dots, or LRDs. Each one is tiny by galactic standards, smaller than 500 light-years across, and some are smaller than 150. But each one hides a supermassive black hole with a mass between 100,000 and 10 million suns. The textbook says supermassive black holes grow slowly, co-evolving with their galaxies. These objects show up with the black hole already enormous, and the galaxy barely keeping up. Picture a region smaller than the distance across a single spiral arm of the Milky Way, small enough to stuff inside some nearby nebulas, with millions of suns worth of black hole crammed inside. The accretion signatures are wrong too. X-rays and radio emission come in far weaker than any standard model predicts. Physics handed us a rule book on how black holes grow, and the universe apparently used it as a napkin. We built a $12 billion telescope to look back in time, and what came back was a pile of paperwork with one entry missing. One bullet point quietly got erased from the textbook. It was the first. A galaxy that shouldn't be old enough. Every grown-up was once a kid. Galaxies are supposed to work the same way. Small, faint, messy at the start. Jade's JWST 14.0 skipped the awkward phase. 300 million years sounds like forever, until you learn what this galaxy managed to pack into it. James Webb confirmed it in 2024 through the JADES survey, and its redshift works out to about 14.32, which translates to roughly 290 million years after the Big Bang. The galaxy is 1,600 light-years across, holds around 500 million suns worth of stars, and in March 2025, an ALMA follow-up detected oxygen inside it. Oxygen at that age was not predicted by any formation model. The first generation of massive stars needs tens of millions of years to forge heavy elements in their cores, then explode and scatter them. This galaxy had room for maybe 10 such generations. Its oxygen signature says it has been running hot for twice that long. It is like walking into a daycare and finding a toddler doing freshman year chemistry. We did not just find one early galaxy. We found a whole population of them, roughly 10 times denser than pre-Webb theory allowed. Every simulation told us what the early universe should look like. None of them looked like this. The universe ran ahead of its own timeline, and it hasn't explained itself yet. Gamma rays from another galaxy. Stand outside on a clear night. Nothing in the sky should hurt you. For 140 milliseconds in 2020, that assumption got very close to being wrong. The burst that flashed across every orbiting detector looked exactly like something scientists thought had only one cause, until it didn't. On April 15, 2020, a short gamma ray burst hit Earth's detectors from the starburst galaxy NGC 253, about 11.4 million light-years away. The duration was 140 milliseconds, barely longer than a blink. And that is where another page of the textbook got crossed out. Short gamma ray bursts had been treated as near synonyms for neutron-star mergers, two dense cores colliding in the dark. This event proved that list was incomplete. A magnetar giant flare, the twitch of a single terrifying dead star, can mimic the signature exactly. Try a scale ladder for the power involved. A candle on your kitchen table radiates about 1 watt. The sun, in a single second, pours out enough energy to vaporize Earth's oceans many times over. This magnetar flare released in 140 milliseconds, more energy than the sun has emitted across its entire lifetime to date. A single magnetar, 11 million light-years away, briefly made every deep space detector on Earth twitch. Good news, it wasn't a neutron-star collision. Bad news, it was somehow scarier. The magnetar did not shout across the void. It whispered, and the whisper was louder than any star we know. The comet that isn't ours. Our solar system bakes a certain kind of comet. Centuries of observation wrote the recipe. The object called 3I Atlas didn't grow up in our kitchen, and the chemistry gave it away. Its carbon dioxide levels aren't just high, they are the highest any comet has ever shown, measured by any instrument anywhere. The Minor Planet Center announced it on July 2, 2025, making it only the third confirmed interstellar object ever detected, after Oumuamua and 2I Borisov. Its nucleus is about 1.5 miles across, on a clearly hyperbolic path, the kind of trajectory that will carry it right back out of the solar system once it's done with its swing past the sun. The James Webb MIRI instrument measured a carbon dioxide to water ratio of roughly 8:1 in its coma. Most of the comets born around our sun run that ratio below 0.3. That puts 3I Atlas more than 25 times higher than the comet textbook average. Methane was detected for the first time in any interstellar object. Atomic nickel, too. Comets were supposed to be tidy cosmic time capsules with predictable chemistry. 3I Atlas shows that what counts as cometary depends heavily on which star the comet grew up around. Every comet textbook on Earth is suddenly a textbook about local comets. The composition even shifted between before and after its closest approach to the sun, which means the interior of this thing is different from the exterior. An interstellar guest showed up, and its chemistry implied a much weirder kitchen. The solar system just found out there is more than one way to cook ice. 40 pairs of orphans. Planets are supposed to be raised. They orbit stars. They grow up inside protoplanetary disks, the donut of gas and dust around a young star, where the usual rules do the usual work. 40 pairs in Orion didn't get the memo. In October 2023, astronomers Samuel Pearson and Mark McCaughrean released a James Webb survey of the trapezium cluster inside the Orion Nebula, and they found 42 candidate pairs of Jupiter-mass objects, orbiting each other, orbiting no star at all. The masses range from roughly 6/10 of Jupiter up to about 13 Jupiters. One of the lead authors phrased the finding in a way scientists almost never phrase anything. He said something was fundamentally wrong with our theory of planet or star formation. A single rogue Jupiter-mass planet is already hard to explain. Two of them bound together multiplies the impossibility. 40 such couples in one cluster moves the problem from anomaly into entire missing chapter. Planets were believed to always form inside disks around stars. These objects suggest either a formation channel no model has captured, or that planet itself is a fuzzier category than anyone had settled on. Honestly, they aren't orphans at all. They're couples, cosmic couples, drifting together through a nebula, with no sun, just each other and the void. If you ever feel lost, remember, somewhere out there, two Jupiters are drifting through Orion, holding each other together because they have no one else. And there are 39 other couples doing exactly the same thing. The universe, it turns out, doesn't ask permission before writing its own exceptions. Speaking of things the universe never warned us about, if you find stories like this one worth your time, I post videos like this regularly, and I'd really appreciate if you subscribed. Thanks. A signal from a graveyard. Old galaxies aren't supposed to have young engines. In 2024, a signal kept flashing from one, and the cozy model astronomers had leaned on for a decade started to fall apart. Nothing that was supposed to make this signal lives anywhere near where it came from. The fast radio burst, first detected in February 2024 by the Chime Observatory in Canada, repeated 22 times over the next 5 months. The host turned out to be a quiescent elliptical galaxy, roughly 11.3 billion years old, about 2 billion light-years from Earth. No recent star formation. None. And the burst wasn't coming from near the galaxy's center either. It was originating more than 130,000 light-years out, past the main stellar body, in the sparse halo. Try a scale ladder. The Milky Way's star-forming disk is about 100,000 light-years across. This fast radio burst is sitting farther from its host's core than our entire disk measures. And its host hasn't made a new star in billions of years. Fast radio bursts had been treated as a near-exclusive signature of young magnetars, the recently dead cores of hot blue stars. This one comes from a place where magnetars are not supposed to be forming at all. Picture a retirement home suddenly broadcasting drum solos. The cemetery is apparently still paying its electricity bill. Something in that dead galaxy still had something to say, 21 more times. A ring too big to be real. For a century, one rule held the whole picture together. Zoom out far enough and the universe looks the same everywhere. The Big Ring didn't follow that rule either. There is a theoretical cap on how large any single structure in the universe should be. This one blew past it, and brought a friend. The Big Ring was announced in January 2024 by Alexia Lopez at the University of Central Lancashire, using data from the Sloan Digital Sky Survey. It is a roughly circular arrangement of galaxies and quasars, about 1.3 billion light-years across, sitting 9.2 billion light-years from us. Standard cosmology caps any coherent structure at about 1.2 billion light-years, so the Big Ring is, by itself, bigger than the universe is supposed to allow. Its neighbor, the giant arc, which Lopez found 3 years earlier in the same patch of sky, spans about 3.3 billion light-years. Ladder the scale. The Milky Way is 100,000 light-years across. A typical galaxy cluster spans a few million. The Big Ring is 1.3 billion, roughly 13,000 Milky Ways laid end to end. The cosmological principle, the rule that the universe is uniform on large scales, used to be one of the shortest entries in the textbook. It is getting shorter. Two megastructures bigger than the allowed limit sitting next to each other says that principle is either incomplete or quietly wrong. It is so big that big stopped being the right adjective. Two of these in one neighborhood, a cosmologist's worst Tuesday. If the universe is supposed to be smooth, nobody told this corner of it. When galaxies pick a side. Flip enough coins and you get roughly half heads. The universe, spinning galaxies in every direction, should look like a giant coin toss. It doesn't. The imbalance is so large that you can see it by eye, in a field where by eye is almost always wrong. A Hubble Ultra Deep Field study counted 24 clockwise spirals and 10 counterclockwise spirals out of 34 total galaxies. The probability of that imbalance showing up by chance came out to about 1.2%. Then, in 2025, a James Webb JADES survey analysis expanded the sample and found counter-rotating galaxies showing up about 50% more often than co-rotating ones. The effect grows stronger at higher redshift, meaning the earlier the universe, the sharper the bias. Ladder the statistics. A fair coin flip gives a 50-50 split as the sample grows. An 8 to 10% tilt across 34 galaxies would be surprising. A 50% tilt across thousands of galaxies would not be surprising. It would be impossible under the standard model. The universe was assumed to be isotropic on large scales. That means the same in every direction. No cosmic north, no cosmic spin. A universal preference for one rotation direction means isotropy may be a simplification astronomy has been leaning on too hard. Scientists spent decades proving the universe has no favorites. The universe may have been quietly disagreeing the whole time. The galaxies are picking a side. Nobody told the galaxies there were sides. Someone is going to have to explain why. The textbook keeps losing its rules to footnotes. Two clocks that disagree. Two good clocks should tell the same time. The universe is being measured by two very good clocks, and they disagree by almost 9%. For a decade, astronomers hoped the gap was going to quietly close. In late 2024, that hope died. The Hubble tension, as astronomers call it, is a mismatch between measurements of how fast the universe is expanding. From the local universe, based on exploding stars and pulsating stars, astronomers get one expansion rate. From the early universe, based on the leftover glow of the Big Bang, they get a different one. The two disagree by about 8 or 9%. In December 2024, a team at Johns Hopkins used James Webb to remeasure the distances to the same set of galaxies Hubble had looked at, and the two telescopes agreed with each other to better than 2%. Ladder the precision. Two telescopes of different design disagree by less than 2%. Two methods of measuring the universe's expansion disagree by 8 or 9. The gap between the methods is roughly 4 times larger than the best error bars in the field. Everyone expected better data would close this. Better data made it sharper. Science advanced. The mystery got bigger. It is like finally buying a second watch and finding out both of them are right, and they still don't agree. Something between the early universe and this one is missing. And we still don't know what. The constant that isn't constant. The fate of the universe depends on one number. For a century, we thought that number was frozen. In March 2025, a survey of 11 billion years of cosmic history suggested it might be slipping under our feet. If dark energy is weakening, the thing the universe has been doing for 4 billion years could stop or reverse. The Dark Energy Spectroscopic Instrument, known as DESI, is a telescope in Arizona with 5,000 tiny robotic eyes, each one staring at a different galaxy. In March 2025, the DESI team released its second data run and reported a 4.2 sigma preference for evolving dark energy over a fixed cosmological constant. That signal got stronger when they stacked it against the leftover glow of the Big Bang, exploding white dwarfs, and weak gravitational lensing. Latter, what those numbers actually mean. At 3 sigma, physics calls a result interesting. At 4 sigma, it calls it evidence. At 5 sigma, it calls it discovery. DESI is at 4.2, and the data keeps growing. The long-run story of the universe used to be accelerating expansion forever. That story was written around a number we now suspect is drifting. Albert Einstein introduced the cosmological constant in 1917, then reportedly called it his greatest blunder. Astronomy spent a century insisting he was right. The universe is now gently suggesting he was right. Twice. About being wrong. The entire future of the universe depends on a value that is apparently still making up its mind. The textbook never had a final chapter. The universe is still writing it. If this sparked your curiosity about the places where the universe quietly breaks its own rules, consider subscribing so you don't miss future space content. Thanks for watching.